Hi everyone, this is Sam Gabriel. Welcome to another video. In today's video, we're going to discuss how to deploy a Kubernetes cluster using the k3s flavor of Kubernetes on top of vSphere using Terraform and also the Packer image that we had created in a previous video. So let's get started. Okay, so I have a blog post here that goes through the details of everything I'm going to talk about today. But I'm going to hit the highlights today and also show you a demo of how all of this works. All right, let's make this a little bit bigger. Okay. So some of the things or some of the tools that we're going to use today are vSphere, of course, and Terraform Cloud, where we're going to run our Terraform builds. GitLab as our CI/CD pipeline. We're going to use Vault to store the Kubernetes kube config at the end of the run. And we're going to run k3s, that's our Kubernetes flavor. And Docker is also going to be used for our cloud agent that's going to run Terraform locally in our vSphere environment and talk to Terraform Cloud. Okay, so I'm running this on vSphere 6.7. And for the purposes of this demo, we are using Terraform Cloud for Business that enables us to provision locally using Terraform Cloud. You could definitely modify the code to use a local Terraform run, for example, to run this locally with Terraform open source. Now, we're using HashiCorp Vault open source for this. Of course, this can be run with Enterprise, no problem. We're using Docker and also the GitLab free account. And let's take a look at the workflow that we have. And let me make this a bit bigger as well. And actually, before we get into this, just to make best use of the time we have, let me go ahead and trigger a run for our environment to start building while we are discussing the details. So here's my Visual Studio Code, and you can see the GitLab CI YAML file that's going to get everything going for us. So let's go ahead and quickly commit this and say build environment. And I'm going to commit that and just simply push that. So basically, I'm not running any merge requests or anything like that. It's just a simple push that will get pushed to the main branch, and things should get started for us. So let's go ahead and verify that through our pipelines. There we go. So it's running, and we have two stages, a build stage, and we also have a deploy stage. Build stage is to build Terraform VMs, and then the deploy stage will deploy the k3s cluster for us. Okay, with that, let's get ahead and let's go ahead and take a look at this diagram of how everything kind of ties together. So I'm on my desktop, and the very first thing to realize is that we are utilizing a Terraform VM module that we created and store inside of Terraform Cloud's private module registry. And to give you a quick view into that, if I pivot over to my Terraform Cloud screen and go into registry, you can see that I have multiple different modules in the registry. vSphere VM public. This is the module that we're going to use, and this is the module that actually creates the VMs using Terraform. So in here, you can change the different versions. This is tied into Git tags. So if you want to make a change to the module, you make the change and then you update the version, the Git tag version, and it will get updated here in Terraform Cloud's registry. You can see the README file. I don't have much in here. The inputs. So these are all the expected or required inputs to this module to get it to provision. So things like the IPv4 address, the gateway, the netmask, the name for this VM, the RAM, the CPU, and a bunch of other things, disk size. And as you can see, the resource that's going to get provisioned is a vSphere virtual machine VM. Okay. Very good. So let's go back to our diagram. So the very first couple of steps here, I'm just showing you how you can use a a GitLab repo that's hosting your Terraform VM module, and that is tied into Terraform Cloud using a VCS connection. And as I mentioned, when you're making updates to the module, you just need to update the Git tag, and when you push it in, it will get reflected inside of Terraform's private module registry in the cloud, and you're good to go. Okay, so the next step is to actually look at our repo that is hosting the Terraform k3s build, and this is what we're trying to build, the Kubernetes cluster. And in here, we're gonna do a push, just as I did right now, commit and a push will automatically trigger a CI/CD pipeline within GitLab, and GitLab's CI/CD is gonna do a bunch of things. So the first thing in step 5 here is that it's going to talk to the Terraform workspace that in the cloud to build this k3s VM. So let's take a look at that. So if I go back into my workspaces in Terraform Cloud and just search k3s here, you'll find that we have a workspace that we call VMware k3s infra. And in here, you can see that it's applying. This is exactly what's happening through the pipeline. But basically, we have a few variables that we define here, and these are all sensitive variables. So the SSH username and password for the VMs we're creating, the vSphere credentials to talk to vCenter to get everything configured through vCenter. And in the settings section, you can see that we are running execution mode agent. And if you're not familiar with Terraform Cloud agents, it's basically a way to be able to provision locally. So in order not to have to open a firewall inbound into the vSphere environment where I have the Kubernetes cluster being built, we have an agent running internally in this vSphere cluster that reaches out to the Terraform Cloud periodically, asking for any jobs that it's ready to provision. Once there's a new job ready for it, it's going to go ahead and start provisioning locally. Well, it's similar to other products that do the same thing. GitLab has GitLab runners, Azure DevOps has agents as well, and so on. So it's a similar idea. Okay, now if we go back to our diagram here, as I mentioned, once you trigger this in Terraform Cloud, it's going to send the job to the cloud agent is going to see that there's a job waiting for it. In my case, I have a Docker container hosting this cloud agent inside of my vSphere environment that's going to do all the provisioning for us locally. So this cloud agent is going to reach out to a Packer generated template that I mentioned in a previous video. I'll put a link in the description to it. And this basically is going to grab this template from vSphere. So if I pivot over to vSphere real quick and look at our templates, this is the template I was talking about earlier. So this is a template that was generated by Packer, and we're going to utilize this template in our builds. And you can see here already we're building the 3 master nodes for the Kubernetes cluster with 3 worker nodes. It's still provisioning, so they're not running yet. We'll get there once the job is complete. Perfect. Now that we're pulling this specific template to build all our VMs, we have 6 VMs as I just showed, 3 for the master nodes for an HA, high available Kubernetes cluster, and 3 VMs for worker nodes, which will do all the jobs, run all the jobs for us. Okay, so this is our Kubernetes cluster. So the first phase or stage of the GitLab CI/CD pipeline is to deploy those 6 VMs. And these 6 VMs, once they're deployed, the second phase is the deploy phase where we're going to configure k3s on these. So basically, we're going to specify 3 of those nodes to be master nodes, 3 to be worker nodes, join them all together, get the cluster up and running, and then we're good to go. The very final step, step 10, is to get a hold of the kube config file, which allows us to connect to the cluster and run operations against it. This is a secure or a very sensitive file that needs to be securely stored, and therefore we're using Vault, HashiCorp Vault, to store this. base64 encoding the file and sending it into the KV store inside of HashiCorp Vault, where we can retrieve it later and go ahead and use that to run kubectl commands against our cluster. So hopefully this has been a good overview of what we're doing. Let's go ahead and take a quick look at our pipeline, see how it's doing. It still seems to be in the build phase. We can go in and take a closer look, see what's going on. Okay, so it's still building. As you can see, if I scroll a little bit higher, you can see the different resources it's going to build. They're all the same. It's the same kind of VM, but we have 6 of them, 3 for masters and 3 for workers. So you can see that being provisioned. We use 4 each within the modules. So you can see you see worker test 1, master test 2, worker test 2, worker test 3, master test 1, master test 3, and so on. So it's looping through all of them, and in parallel, going to create all 6 VMs for us in parallel. Okay, so let's leave this for now. Let's go back to pipelines. So we'll see when this is complete. And let's take a closer look at the config. Okay, so we went through all of this. The folder structure is basically a GitLab CI YAML file that stores a pipeline. And I got the main Terraform file. I have an output file, which I really don't use. And I got a variables definition file. Then I have a vars auto tf-vars file that is static. And then there's also a script, a shell script that creates an auto vars file that puts in the 3 master nodes names and IPs as a map, and also the same thing with the worker nodes. And we'll get into that in just a bit. There's also a script called install k3s, which is a shell script that will install the cluster for us. All right. We kind of talked about Terraform Cloud agent, and there's some documentation here as to how to get this going. But basically, in my case, you have to define the TFC agent token and also give it a name. And then here's the Docker run command to run this agent in your local environment. And if you go into the settings page of Terraform Cloud and go into agents, you'll see the agent sitting here called Home Lab, for example, and it's running. Okay, perfect. And it's idle because actually the build has succeeded. All our VMs are up and running now. Master test 1, test 2, test 3, worker test 1, worker test 2, worker test 3. And at this point, we're in the deploy phase where we're deploying the actual K3s cluster. Perfect. Quick look into the Terraform module that we're using. And if you're not familiar with what a Terraform module is, think of it as a piece of reusable code that we can deploy everywhere. In this case, we're leveraging that same piece of code or module or 6 times. We're using it 6 times for the 6 VMs that we're deploying. So this is what it looks like. I have a locals block with the different parameters that I'm going to reuse, different variables that I'm going to use. And I have a few data blocks that I'm capturing: the vSphere data center, the data store, the compute cluster, network, the template that I'm going to be using, and this is the Packer template we mentioned before. And then finally we have a resource block, and this resource block will talk about we'll configure and provision the VM that we need. So some of the variables here, of course, CPU, RAM, network related block, a disk related block. In this case, we're using thin provisioning since the actual template, we're using the template for this is thin provisioned. Same thing with eagerly scrubbed is false. And the size here, there's a conditional. So if the disk size is not specified, or that variable has nothing in it, it's going to use the actual default disk size that came with the template. Otherwise, we will use the disk size we specify in the variable. In our case, we will explicitly specify the disk size for both the master nodes and the worker nodes. All right, cool. Cloning, we're cloning that template I mentioned, the Packer template. And this section is actually important where we're using Cloud init to provision our VMs. as opposed to using the Linux customization block, if you're familiar with that. And initially I used to use the Linux customization block, but I ran into a few issues with the way Ubuntu 2004 runs and how they've moved away from the traditional networking model that you used to use, and now they use NetPlan, and that's not really reflected very well in this customization block. So it tends to come up, the VMs tend to come up with a DHCP IP as opposed to the static IPs that I specify. So Cloud Init is really the way to go. And shout out to my colleague Kalen. He's been tremendous help in this, in getting the Cloud Init configuration working for us. So basically there are two files. There's a metadata file and a user data file that get passed in here. And a quick peek into these, you can see the metadata file and the user data file. So the metadata file, you'll have some networking information. So for example, Ethernet, DHCP is false. I'm feeding in my IP addresses here dynamically. So you can see the IPv4 address for each one of the 6 VMs is going to be passed in here. The DNS servers as well will be passed in. And this section also to explain or specify the mode in which we're going to have the disks. So to enable thin provisioning and the disks to grow dynamically, you need this block. The user data file also, you can have a few things in here. You can add a new user. You can add an SSH authorized key, a public key, so that you can SSH into the machine, and some sudo commands also to be able to use sudo with no password, and so on. You can add packages as well. Just for example, we can have the tree package in here. I put it in here just as an example. So yeah, Cloud Init is amazing to use. So it's not only for cloud environments, it's also available for a vSphere environment, as you can see here. All right, the next piece that I want to talk about is the actual GitLab CI/CD pipeline itself and what that looks like. I've broken it down here in the blog post into 3 sections. First section takes care of the variables that we're feeding in here. So let's take a look at the variables that I'm using in here, and some of them are straightforward, like the user that I'm going to use inside of the k3s cluster for each of the nodes is Ubuntu. The version that we will use for Kubernetes, version 1.21, and the context name that we will use, in this case k3s VMware test. The master names and worker names, we're passing those in as lists. So this is where you would specify the names of the master nodes and worker nodes, and the quantity, how many you need. So if you only needed 1 master node, you can just remove master 2 and master 3, and then you'll end up with only 1 master node. Similarly with the worker nodes, you can add or remove some of those nodes. But when you do that, just make sure that you also do the same thing for the IPs to match. So basically master test 1 will be this IP, master test 2 will be this IP. Same thing with the worker nodes. So they map to each other here. The Vault address, as you can see, this is what we're going to use, and it's actually a Kubernetes address in here. So it's the service name, then the namespace, and then the service cluster local, and it's running on port 8200. So we, as part of this, remember we said we're going to deploy, or we're going to use the kubeconfig, deploy that into and save it into a KV store inside of Vault so we can securely access it. Well, we need a way to authenticate into Vault. We have to be able to get into Vault to actually write the data. And the way to authenticate into Vault, in this case, we're using the Kubernetes authentication method. Now, GitLab is using a GitLab runner inside of a separate Kubernetes cluster that I have internally. This cluster is this one here. You can see master 1 and worker 1. It's just 1 master node with 1 worker. So the GitLab runner, I have 2 GitLab runners. There's one that's running in a VM, in a Docker container in a VM, and then I have also GitLab runners that are inside of Kubernetes. So this makes it very convenient. The Kubernetes auth method is super convenient because now I can access Vault through the Kubernetes authentication method, effectively removing the secret zero problem. And I have a whole section on this, a whole video talking about the secret zero problem with Vault. But basically now what we have is that we have what we call an agent injector container that's sitting inside the cluster, listening for any annotations that it sees as part of a deployment or a pod. And that's why we have these annotations that you can see here within the variables, the GitLab variables. And what happens is whenever we see any of these annotations with the GitLab runner coming in, Vault, the Vault agent injector is going to inject a Vault agent sidecar with the runner. And this is where we say agent inject is true. And it's going to deploy a token. It's going to put a token inside of a volume. And you can see the path to the volume is app secrets. And the token will live in a file called token. So it will be app secrets-token. And now I will be able to get access to Vault through this token. And what we'll do is we'll see later in the GitLab CI/CD pipeline, where we are going to export this token from this path, and then that's how we're going to have access into Vault. Okay, so that's the variables section. The next section in the pipeline is building the 6 VMs with Terraform. And as you can see here, we're grabbing a user. Now, there is a way to get variables passed on between different stages of a GitLab pipeline. And that is by using the .env command here. So you have to write it into a .env file. In my case, I'm using build.env. So this user, just for demonstration, I'm using I'm echoing the current user, putting in the build.env. I'm going to get it from the next stage. You could also use outputs from Terraform, for example, add them to the build.env. And any variables that live in build.env will be accessible in the next stage. So user equals this variable user, which was exported from who am I. Basically, whenever you look up user in the next stage, you will get the user, which in this case is app user. We're creating a directory here, and we need a TFC token to be able to access Terraform Cloud. So we are building this file, this JSON file, and we're putting it in this particular directory to be able to get the runner, the GitLab runner, to access Terraform Cloud to run the Terraform operations. In here we have a shell script that I mentioned earlier that creates an autovars file for us with the different master names, worker names, master IPs, worker IPs that will be used within our Terraform script. Then we run Terraform init with this flag backend config with the token that we have stored locally inside of GitLab, GitLab CI/CD variables section. We could technically also have stored this inside of Vault and called it from Vault. So either way works. I tend to like to have it in Vault as a central location. It's the best way to do it, obviously, so that you don't have to worry about where this is stored inside of your GitLab folders and projects. So it's definitely better to have this stored in Vault. For my case, just for simplicity, I just got it from the GitLab variable section. Then we format the Terraform, we validate it, and we also look to apply this and auto approve this so that we don't have to manually approve it. As part of our pipeline, you always want to auto approve. And we're outputting the output. Actually, I don't have any output, so this was left from previous trials. And as I mentioned before, some of the outputs you might want to also include in the build.env so you can grab it from the next stage of the pipeline. In this case, you have to include this artifacts, and this is how it's passing one artifact to the next stage, which is this build.env. Tags, this is in Kubernetes, so it means that it's going to use the Kubernetes cluster to run the runner. Perfect. Now let's go ahead and look at the Terraform file itself. In this case, we have a main.tf file. And in this main.tf file, we have the provider is vSphere. Always pin the version of the provider you're using. The backend is remote. It's using Terraform Cloud. So here's the organization name. There's the token that gets passed from within GitLab here. And when we run Terraform init backend TFC token, this gets populated in here. So you don't want to put your actual token in here and push that into Git, right? So this is how we do it from a variables perspective. The workspace we're running with is this workspace that we saw earlier. And then we have the provider block. And this is where we're calling the modules that are stored in the private module registry within Terraform Cloud. We're running a for each statement that loops over this module 3 times since we specified 3 master nodes. And every time it's calling the source. This is the source of the module, the VM module. It's stored inside of Terraform Cloud. If you're using Terraform Enterprise, then you just put the host name of Terraform Enterprise here, followed by the organization name, followed by the actual name of the module. So an easy way of doing it is to go to the registry. If you don't know what the actual path is, go in here, and once you're inside the module, it gives you actually a quick block that you can copy. So you can see the source. If I zoom in a little bit, you can see that the source is right here. It gives you the entire path of the source. You can just copy that, and you're good to go. Okay, so it's going to use the module. These are all the inputs that are required by the module. We're feeding those in. We're also doing the same thing on the worker side of things. So 3 worker nodes, exact same thing will happen. As you can see, with code reusability, we're applying the dry principle, do not repeat yourself kind of thing. So in essence, it's a very small file. All it's doing is calling on 2 modules, one for the master nodes, one for the worker nodes, with different variables. Excellent. Now let's take a look at the variables files. And we have 2 actually. We have a static one called static autovars, and we have a dynamically generated one. Now, one thing to note here is that Terraform Cloud, if you go into the workspaces, doesn't allow you to use a Terraform.tf vars file. So if you go into the variables section and read a little bit here, it says these Terraform variables are set using a Terraform.tf vars file. To use interpolation or set a non-string value for this, click on HCL checkbox. But in here, these variables are used for all plans and applies in the workspace. Workspaces using Terraform 0.10 and above can load values from an auto TF vars file in the configuration. So it doesn't allow you to use a Terraform TF vars file because locally it will override this with these. These will be written to a Terraform.tf vars file. So basically, if you want to store any variables or pass any variables into Terraform, you need to put them in this format, in a file called auto.tf vars. And that's what we're doing. We have two files, the static one auto.vars that has all the static configuration that we have. So the number of CPUs, the number of cores per socket, RAM, disk size for the master and for the worker nodes. Some other things that we're looking at in terms of the names of the data store, the network, the domain inside of vSphere or vCenter, and also the DNS server list that we're using, the gateway, the mask, the template name. So these are pretty static for our case, across the 6 VMs. However, when it comes to the other file, vars file, we are dynamically creating it. And the way we're doing this is we have a shell script that is grabbing all the lists of master names, worker names, master IPs, worker IPs, looping over those arrays, and assigning or creating this below here. So this is what we're actually creating in this ips.auto.tf vars file. So essentially dynamically building the master nodes and worker nodes in this map, two maps. So you have the master node map has a key of the name of the node that I want, and the value is the IP address. Same thing with the worker nodes. Now, this makes it dynamic in nature because now we can basically, once we pass this into Terraform, if we decide, as I mentioned earlier in the GitLab config in the very beginning, to only have one master node, then this will automatically get populated with only master test 1, and these two will not get populated. So we don't have to worry about doing anything manually inside of the config. So that's that with the variables. The final section is to look at the GitLab pipeline that allows us to deploy the K3s cluster. And in this case, at this point, we would have our 6 VMs already provisioned by Terraform, ready to go and ready to deploy Kubernetes. So the first couple of lines here, we're looking at exporting, getting Vault, getting the runner ready for accessing Vault. So we have a Vault token. As I mentioned before, it lives in the app secrets token file within the container's volume. So we can cat that and export it into the Vault token. The Vault address, what we manually specified in the variable section of the pipeline. So we're exporting that as well as an environment variable. We're creating a config, an empty config file so that we can have that ready for our kubeconfig. And we are creating a directory for a .ssh directory where we can store our private key that we were required to SSH into the 6 VMs. So there is a script, install k3s shell script, that is used, and that script needs to be able to SSH into the machines, into the VMs to configure Kubernetes. So we need to have this IDRSA private key stored in .ssh file. Now, we could have stored this inside of Vault and called it and put it in here. That's completely fine and the recommended approach. But again, for purposes of this demo, I put it inside of the inside of GitLab's variables directly. Okay. So then once we call on the script, this is where we are base64 encoding the config and writing this into Vault. As you can see here, this is getting written into Vault at a certain path in the KV store. Now, there is an option to opt not to use Vault if you don't have Vault set up. It's a highly insecure, as you can see here, I call that out, a highly insecure option where you could actually pass this config, kubeconfig, over to as an artifact that you can grab from the pipeline when the pipeline completes successfully. What you need to do is uncomment this line and also uncomment these lines. The issue with that is that this lives forever basically. Even though I tried expiring in an hour, the file will actually persist inside the pipeline. So whoever has access to the pipeline will effectively have access to the Kubernetes cluster. So you don't want to do this in production. Utilize Vault, which is a more secure solution than using the artifacts. So that's pretty much it with the GitLab CI pipeline. We've gone through the 3 different sections that I mentioned before. One thing I want to talk about is the installation. The k3s install script that we're using utilizes a utility called ketchup, and feel free to take a look at this in more detail. But basically, it's a very easy way of deploying K3s cluster. First thing you want to do in the script is basically download the utility and install it. And what we're doing is that we're going to install a master node basically on one of the VMs. And once we do that, we're going to loop through the other 2 VMs, the other 2 master VMs, and join them to the master. And then now we have a cluster of 3 master nodes. And then do the same thing with the worker nodes. We're going to join them to the entire cluster and loop over each one of those worker VMs and join each one to the cluster. Finally, we want to make sure that we taint the nodes, the master nodes. So we loop over the master nodes, we taint them to no schedule so that we don't allow anybody to schedule jobs on those master nodes. They should be only for the control plane, and then any jobs get configured and run on the worker nodes themselves. This is what we should see at the end. I have a bunch of commands that you can run. So you need access to Vault, so you need a token into Vault. So you run this on your desktop. Also the Vault address. And here we're getting the actual kubeconfig from Vault. So we base64 decode. We put this in a file called mytestconfig. Export our kubeconfig. Run kubectl get nodes. Get all kubectl get all for the kube system namespace. And here's the output that you'd expect. So 3 master nodes, 3 worker nodes. The master nodes, as you can see, the role is control plane, etcd, and their master. The worker nodes are none. They're basically worker nodes. And the version for Kubernetes, the internal IPs that we specified before, and so on. When you run the kubectl get all in the kube system namespace, you also see all the pods that are running. Everything is running perfectly. There is also a very neat traffic ingress that allows us, it's a load balancer service which allows us to access the cluster internally, and as you can see, it's referencing all the nodes in the cluster that it will actually talk to. So once you expose via an ingress any of your services, you'll be able to contact that service internally inside of Kubernetes. So that basically concludes the config section. Really 3 takeaways out of this. First one is that infrastructure as code works just as well in an on-premises environment running VMware in our case as it does in cloud environments. And I kind of mentioned that in a previous post and a previous video that starting to see a lot of traction on the on-premises side of the business, whereas the cloud side has been using infrastructure as code for a while now. We also you can use Vault to secure your builds when you tie this into your GitLab pipelines, and leveraging benefits of Terraform Cloud in an on-premises environment using the cloud agents that we saw earlier. So not only can you provision in cloud, but you can also provision on-premises with these cloud agents. Now with that, let's take a final look at our results here. We saw that we've provisioned the 6 VMs here. We saw that the pipeline has completed successfully. So if we go in here, take a look at our pipeline. Job has succeeded. We actually run inside the pipeline the kubectl get nodes, so you can see all the nodes have been deployed. So that's perfect. But I want to see this locally, right? I want to run this on my local machine. So what we can do, let me clear this because I was doing this from an earlier test. If I go to my README section, I have the different commands. I've already exported my Vault token and also my Vault address. So now what I want to do is basically call on Vault and drop this into my test config file. Let's export this. Let's make this a bit bigger. And go like this. Go like that. Okay, let's run our kubectl get nodes command. And there you have it. We have our nice shiny cluster with the different nodes, exactly what I showed you in the previous output. And if you also want to see the output of all the pods and services and deployments inside of the kube system namespace, you can do that as well. And one last thing, in case you don't believe me, you'll see that if you go inside of Vault, I have multiple secrets engines, but the external secrets engine, this is where I'm storing the actual k3s config that I just called upon. And you can see the base64 encoding of that. Obviously, this will all get destroyed right after this recording, so don't care about the security of this. But this kind of shows you how you can easily store that config inside of Vault and call it later. So hopefully this has been helpful to show you an entire end-to-end deployment of a Kubernetes cluster using K3s on vSphere, utilizing Terraform to provision using GitLab as our CI/CD pipeline, but also using Packer and using the templates that we stored from previous video inside of vSphere and calling that as we are building Terraform. Thank you for watching.